Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a nice equation with complex numbers. A really good quadratic equation that we can solve in different ways. Alright, let's get started. First method, I'm going to go ahead and use the quadratic formula. But let's go ahead and put everything on the same side first. Quadratic formula basically applies to any quadratic equation even when the coefficients are non-real complex numbers. So from here z becomes negative b. Notice that the coefficient of z is 1, negative 1, plus minus the square root of b squared, which is 1, minus 4ac. A is 1, so I'm just going to write the c and then divide the whole thing by 2 and I should be done, right? No. You need to simplify it. Let's go ahead and simplify it. That's actually where the fun starts. Because inside the radical, we're going to have a complex number. So we need to square root 1 minus 4 plus 4i, which is negative 3, plus 4i. Does that number look familiar? I hope it does, because we're going to write this in different ways. We're going to be using different methods, like I said earlier. So the question is maybe the $1,000,000 question, maybe $500,000, I don't know. What is the square root of negative 3 plus 4i? That's the question we need to answer, because we can't really go any further. I mean, you can leave the answer like that, but leaving something like the square root of a complex number, come on. You could do a little better than that, especially in this case, because the square root of this complex number is actually very nice. Maybe you already know it. Let's find out. Now, we're going to set my number, the square root, equal to a plus bi. You know why? Two reasons. Because, one, it's the name of this channel. Second reason, it's going to help us find the square root. That's why it works. Okay, let's square both sides. And that gives us negative 3 plus 4i equals a squared minus b squared plus 2abi. Notice that bi, when squared, gives us negative b squared. Cool. Now let's go ahead and compare the real parts first. This is the real part, it's equal to negative 3. This is the imaginary part, it's equal to 4. Make sense? So from here, we do get a system of equations. Nice, right? How do we solve it though? Let's divide by 2 here and write this as ab equals 2. Well, you can use substitution, I guess, or a couple different formulas. There are some identities. You can square a squared minus b squared and then come up with something else, so on and so forth. There are so many ways to approach it, but here's what I'm going to use. I want to isolate a squared from here, which I can write as b squared minus 3. And then I'm going to go ahead and square both sides here. A squared b squared is going to give me 4. And then I'm going to go ahead and use this new system, which is actually a little easier to solve, because all I have to do is replace a squared with this, b squared minus 3. Make sense? So let's go ahead and plug it in. B squared minus 3 multiplied by b squared equals 4 from the second equation. Get it? Cool. Now, what am I going to do with this? Distribute, but before I distribute, can I use substitution? Because substitution is, I think, awesome, and you should always use it. Okay, try to find ways to use substitution. Let's go ahead and set b squared equal to c, and let's just remember something. B and a are real numbers. So now b squared is equal to c. So let's replace it with c minus 3 times c is equal to 4. Can you guess at this point? Probably. But let's distribute and turn this into a full quadratic. C squared minus 3c. Hopefully you see what I see. And we get the following equation. This is factorable into c minus 4 times c plus 1 equals 0. And from here we get two solutions for c. C equals 4 and c equals negative 1. But what is c? C is b squared. Remember that? You must back substitute. That's why it's important to take good notes, so you can always refer to your notes. By the way, I gotta tell you, I'm not a very organized person, but when it comes to taking notes, I try to take good notes, and they always help you. So if c is equal to b squared, and b squared is equal to 4, from here we get b equals 2 or b equals negative 2. There are two numbers whose square equals 4. Those numbers are 2 and negative 2. Make sense? And of course, once we know these b values, we can find the corresponding a values, because we know that a times b is equal to 2. Notice that. So their product is always 2. So if b is 2, a is 1. If b is negative 2, a is -1. And there's a good reason behind it, which I'll tell you in a little bit. But let's go ahead and look at the other value of c. B squared equals -1. If you don't see what I see, go ahead and switch them around, and this will probably make more sense. But from here, b is going to be plus minus I. But wait a minute, a and b are real numbers. So this is not acceptable. We're going to discard it. So from here, we get two pairs. And since we're looking for the square root of a number, which is the square root of -3 plus 4i, and it's a plus bi, there are two values. Why? Because a complex number has two square roots, except for 0, of course. Because when you square a number like z and a -z, you get the same result. So the square roots of z, or -3 plus 4i, then is going to be 1 plus 2i and -1 minus 2i. And notice that these square roots are opposites, right? Their squares are equal. Great. Let's go down and plug this in. Remember our equation, z equals -b plus minus the square root of -3 plus 4i, which happens to be these, but you don't really need to write both because the plus minus will take care of the other number. So you can just write 1 plus 2i inside the parentheses. What happens if you write this? You're going to get the same thing. But this one looks more intuitive. I don't know. It's just, I guess, more pleasing to the eye. So what am I going to do next? Simplify this, of course. Let's go ahead and go with the plus sign first. We can just ignore the parentheses. -1 and 1 cancel out, leaving us with I. And then the second solution, maybe I'll call this z sub 1, and z sub 2 is going to be -1 minus 1 minus 2i divided by 2. It's going to be -1 minus I. So those are going to be the solutions for my quadratic equation. But is that the only way to solve it? Well, so far we talked about a single method, didn't we? Let's go ahead and take a look at an alternative. I think there's like 3 ways to approach it at least, but let me just write or, which means an alternative method for finding the square root of a complex number. By the way, the rest is pretty much the same, because once you find the square root, the rest is very easy. So here's what I'm going to do. I'm going to write the -3 as 1 minus 4, or 1 plus -4, and put the -4 at the end. And then just work it out a little bit. This is 1 squared. 4i is 2 times 1 times 2i, because that's 4i, and -4 is 2i squared. Guess what that looks like? 1 plus 2i squared, and with the square root, this will give us the exact same answers as before. Right? Cool. Plug it in, you're going to get the same thing. Or you can do this. And that kind of brings us back to the original. Notice that z equals I is a solution by inspection. What does that mean? I noticed that if z is I, z squared is -1, so these two are going to cancel out, leaving us with z equals I, which is z equals I. Cool. What do you do with this? Use Vieta's formulas. The product is c over a. So this is supposed to be, one of them is I. Let's say this is I. From here, z2 is going to be 1 minus I over I, or 1 minus I times -I. And that is -1 minus I. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.